Good morning. Welcome to Dosage Calculations, Conversions, Reconstitution with Miss Sue. Today we'll be going over some basic metric conversions, some I and O's, some IV push medication, reconstitution, and some basic dosage calculations, such as need over have, drip factors, and mLs per hour. We'll also do a couple of weight-based calculations. I don't do any critical care or pediatric or any complex calculations on here, but I do intend on making another video if you guys like this one. So welcome and let's go. On the video, I will give you time to work out the problems. And if you don't need some of the things, then just skip ahead to what you do need. So first thing we're going to go over is the 5 rights of medication administration. These are things that your employer may expect you to know and something you should consider every time you look at a new order. You want to make sure that these things are present. Okay, is it the right patient's name? Is it the right drug prescribed? Is the dose correct? Do we have the right route? And is it prescribed for the right times? Time intervals can be Q4 hours, which at my facility we write out as every 4 hours because the Q can sometimes cause a mistake. PRN as needed. Q daily, we also write out as daily. And then the other 3 we will abbreviate, and that is BID 2 times a day, QID 4 times a day, and TID 3 times a day. Times may vary with your facility, and however you write it out, you want to make sure that you're following your facility's policy. Also, routes to consider are IM, sub-Q, IV, PO by mouth, PR per rectum, topical, and sublingual. And sometimes you have to give this consideration when you are doing a dosage calculation. The next thing we're going to look at is a label. Okay, we're going to go through the label. Now, the 4 things that most likely you'll be tested on the exam is, do you know the generic name? Do you know the trade name? Are you able to determine the dosage strength? And are you able to determine the form of the medication? However, in the real world, you also have to know how to store this medication and things like that, because you would not want to store it improperly. That could affect the effectiveness or make the medication toxic. You also would want to know the expiration date, and if it were a vaccine or if it was a recalled batch, then you also might want to know the lot number. So for this one, we're just going to look at the 4 things, the generic name, the trade name, the dosage strength, and the form, and then I'll talk to you just about a couple other things real quick. Okay, so for the generic name, generally it's not capitalized. However, sometimes you will see it capitalized, and we'll show you an example of that in this video. But we're looking at oxycodone and acetaminophen tablets. Okay, that's your generic name, and it's underneath the trade name, which is Percocet. And generally, you'll know that name because 1, it'll be capitalized, and 2, it has this little trademark, this little R in a circle behind the trade name, the trademark, okay, protecting the name or the copyright on the medication. All right, and then also it's asking you for the dosage strength. And right here, it tells you that we have 5 milligrams per 325 milligrams. And that is 5 milligrams of the oxycodone and 325 milligrams of the acetaminophen. Okay, and then again, right here on the top left-hand corner, it tells you that each tablet contains 5 milligrams of oxycodone and 325 milligrams of acetaminophen. And then it's asking you the form of the medication, okay, and the form is tablets. That could also be caplets, capsules, liquid, all right, suppository, whatever form that the medication comes in. It could be IV use only, okay? And then here, look at that storage instructions and make sure that you're familiar with that and that the medication is being properly stored. All right, on the next form, these items aren't going to be filled out: generic name, trade name, dosage strength, or form of medication. So I want you to try to figure it out. I'm going to give you a few minutes to do that. Okay, so you should have gotten acetaminophen for the generic name, Tylenol for the trade name, dosage strength of 500 milligrams, and the form of medication was tablets. Okay, on this slide, we're going to go over temperature conversions. So the first thing we're going to do is take a Celsius temperature and we're going to convert it to a Fahrenheit temperature. Okay, so in order to do this, you're going to take your Celsius temperature, okay, and you're going to multiply it times 1.8, and then you're going to add 32 degrees to it. Now, if you look at this little chart beneath there, it says Fahrenheit equals in parentheses, Celsius times 9/5 plus 32. Now, if you take 9 and divide it by 5, that will give you 1.8. So that's where the 1.8 came from, okay? So look at our first example. We have 54 degrees Celsius. We're converting it to a Fahrenheit temperature. So we have our 1.8. We're multiplying that times our Celsius temperature, and we're adding 32 degrees. So our 1.8 is here. We have our 54 degrees, which is our Celsius temperature. And we'll do the multiplication first, and then we'll add it to the 32 degrees. So when we took the 1.8 times the 54, you should have gotten 97.2. Okay, 1.8 times 54. And you got 97.2, and then you added 32 degrees. And you should have came out with a total of 129.2. Therefore, 129.2 degrees Fahrenheit is equal to 54 degrees Celsius. All right, let's look at the next one. Okay, so we're going to do the same thing here. We have 100 degrees Celsius, and we want to convert it to Fahrenheit. So to do that, we're going to take our Celsius temperature. We're going to multiply it times 1.8 and add 32 degrees. So our Celsius temperature was 100. We multiplied that times 1.8, and we added it to 32. So 100 times 1.8 gave us 180. We added the 32, and that gave us a total of 212 degrees Fahrenheit. Therefore, 212 degrees Fahrenheit is equivalent to 100 degrees Celsius. Now, let's see. We're going to do the Celsius to the, we're going to do the Fahrenheit to the Celsius here. Okay, so for Fahrenheit to Celsius, we're going to reverse that a little bit. So this time in parentheses is going to go your Fahrenheit minus 32 degrees divided by the 1.8. So here we do the subtraction first, and then we divide it by the 1.8. So for the first example, we have 78 degrees. We divide it, we subtract the 32 degrees, and then we divide it by the 1.8. So 78 minus 32 gave us 46 degrees. We divided it by 1.8, and that gave us 25.5. Now, depending on what your author says, okay, whether or not you're going to round it. But if you are rounding it to a whole number, which we did here, you use the 0.5 to do that. And since it was 0.5 or higher, that took our number to a 26. If this was 25.4 or lower, then our answer here would have been 25 degrees if we were rounding it. Let's look at the next one. Okay, so the next one, we're taking 54 degrees Fahrenheit and we're converting it to a Celsius temperature. So again, we have the subtraction first. So we're going to take our Fahrenheit temperature of 54 and we're going to subtract the 32, and then we'll divide that by the 1.8. So when we took the 54, we subtracted 32, that gave us 22. We divided it by 1.8, and that gave us 12.22. Again, 55 degrees Fahrenheit equals 12.22 degrees Celsius, and then we rounded it up to a whole number. All right, well, I actually rounded it down because here, see, we have 12.2. And remember, if it's 0.5 or lower or higher, it would go to the next number, which would be 13 degrees. But for this one, it was 12.2. So if it's 0.4 or lower, it stays at that current number. So that made it 12 degrees Celsius. Okay, now we're going to calculate these, and we'll do them on the whiteboard. Okay, so we have 25 degrees Celsius, 98.6 degrees Fahrenheit, 20 degrees Celsius, and 88 degrees Fahrenheit. So let's go to the whiteboard. Okay, the first one is 25 degrees Celsius. Then we have 98.6 Fahrenheit. We have 20 degrees Celsius. And then we have 88 degrees Fahrenheit. Okay, so for Celsius, it's going to be our Celsius degrees. And we'll set all the problems up first, which is 25 times, remember, 1.8. And then we're adding our 32. And that will give us our Fahrenheit temperature. Okay, for Fahrenheit, we're going to take and do the subtraction first. Okay, so we take our 98.6. We'll subtract our 32. And then we're going to divide by 1.8. And here, same thing. 20 times, we're going from Celsius to Fahrenheit. So it'd be 20 times 1.8 plus 32 and 88 minus 32 divided by 1.8. Okay, so let's start with the first one. We have 25 times 1.8. That should have gave you 45. Plus 32 for a grand total of 77. Okay, Fahrenheit. Okay, the next one, we're going to do the 98.6 minus the 32 divided by 1.8. So you should have gotten 66.6 divided by 1.8, and that should have gave you 37 Celsius. And then the next one is 20 times 1.8. That gave me 36 plus 32. Which gave me 68 degrees Fahrenheit. And the last one is 88 minus 32, which equals 56 divided by 1.8. It should have gave 31.1 degrees Celsius. Okay. So if you look here where I wrote it all out for you, okay, 25 degrees converted to 77, 98.6 converted to 37 degrees, 20 degrees Celsius converted to 68 degrees Fahrenheit, and 88 degrees Fahrenheit converted to 31.1 degrees Celsius. This is about the military clock. So with the military time, you don't use a colon between the hour and the minutes. The military time is always displayed in 4 digits. So the first 2 represent the hour and the last 2 represent the minutes. Anything between 0001 and 11:59 is going to be considered AM time. For example, 0100 would convert into 1 AM and 0730 would convert into 7:30 AM. At 12 noon, okay, it converts over to PM time. However, with the PM time, okay, let's think about 1 PM. So if it's 1 PM, what you would do is add 1 to the 12, and that gives you 1300, right? So your time in military time would be 1300 hours. Same thing, if it's 2 PM, you add 12, that would be 1400 hours. Now, let's say it was 1600 hours and you try to figure out the standard time. You would take the 16, divide that, subtract 12 from that, and that would give you 4 PM. Okay. Same thing. You have 2200, subtract 12, that would give you 11 PM. Or 10 PM. I'm sorry. All right, this next little table is a metric chart, and this is for you just to look at, just for review, okay? And I did a couple standard conversions on there that you really should know in your head, but like pounds versus kilograms, teaspoons, how they convert to mLs, tablespoons, how many ounces a cup converts to. Also on here is micro drip and PD drip. Those drop factors are drop factors that you're expected to know. So if they say micro drip or PD drip, they're not going to give you the drop factor. They expect you to know that it's 60. And then ice. Okay, ice is equal to half its volume. So 1 8-ounce cup of ice is equivalent to 4 ounces. You can also go to registernurse.com if you want to do some practice quizzes. Really, they do a lot of I and O practice quizzes. And then if you want to do standard math calculations, you can go to dosagehelp.com. On here, I'm just showing you some basic conversions and how to break them down. So if you're going from pounds to kilograms, you're going to multiply by 1,000. As you see in the example here, 10 kilograms equals 10 times 2.2 or 22 pounds. If you're going from kilograms to pounds, you divide by 2.2. So we have 220 pounds. We divide it by 2.2. That gives us 100 kilograms. Milliliters to liters and liters to milliliters. So when going from liters to milliliters, okay, you're going to the right and you're going to multiply by 1,000 or move the decimal place 3 places to the right. Example, 1 liter equals 1 times 1,000 equals 1,000 milliliters. You're going from milliliters to liters, you're going to go to the left. So you're going to divide by 1,000. Example, 2,000 milliliters equals 2,000 divided by 1,000 equals 2 liters. So you move the decimal point 3 places to the left. Converting milligrams to grams, grams to milligrams, milligrams to micrograms, and micrograms to milligrams. So let's start with grams to milligrams. Again, grams to milligrams, you're going to the right. So you're going to multiply by 1,000. So 5 grams, 5 times 1,000 equal 5,000 milligrams, or move the decimal place 3 places to the right. If you're going from milligrams to grams, you're going to the left. So you have 300 milligrams. You're going to divide. 300 divided by 1,000 equals 0.3 grams. You're going to move the decimal place 3 points to the left. Okay, so 1, 2, 3, and that gives you 0.3 grams. For milligrams to micrograms, you're going to the right. Let me just show you a picture of the scale so you can see what I'm talking about. Okay, so you have milligrams to micrograms, you're going to the right. Okay, so if you're going from milligrams to micrograms, you'll multiply by 1,000, move the decimal 3 places to the right. Kind of helps if you could see this scale. Okay, if you were going from micrograms to milligrams, then you're going to the left, or as I call up the scale. So you're going to divide by 1,000 or move that decimal point 3 places to the left. 1, 2, 3. Okay, let's go back to the other conversion here. So we were doing milligrams to micrograms. So we're going to the right. Milligrams times 1,000, 5 milligrams, 5 times 1,000 equals 5,000 micrograms, or again, move from 5, 3 places to the right, 1, 2, 3, 5,000 micrograms. If we're going from micrograms to milligrams, remember I just showed you that. Okay, micrograms to milligrams. Now we're going up the scale or to the left. So we're going to divide by 1,000 or we'll move that decimal 3 places to the left. All right, so micrograms divided by 1,000, 900 micrograms equals 900 divided by 1,000, or 0.9 milligrams, or move the decimal 3 places to the right. 1, 2, 3. So 900 micrograms would be 0.9 milligrams. Again, look at the scale. Think about the scale. So when you're going down the scale or to the right, you're going to multiply by 1,000 or move that decimal place 3 places to the right. So example, we have 1.5 grams here. We're going to milligrams, so we're going to the right. Okay. 1.5, we're going to the right. 1.5, 1, 2, 3. So 1.5 grams equals 1,500 milligrams. Or you could take that 1.5 and multiply it by 1,000. When you're going up the scale or to the left, okay, you're going to divide by 1,000 or move the decimal 3 places to the right. So here I'm going from milligrams to grams, okay? Milligrams to grams. I have 1,750 milligrams, 1,750. I'm going to divide by 1,000 or move that decimal place 3 places to the right. 1, 2, 3. And that gave me 1.75 grams. All right, let's try it. So now we're going to have 1,000 milligrams, 500 milligrams, 1 milligram, 5 liters, and 110 pounds. So we have 1,000 milligrams and we're going to grams. 500 milligrams, we're going to grams. 1 milligram, we're going to micrograms. 5 liters, we're going to milliliters. And 110 pounds, we're going to kilograms. Okay, so let's write it out here. All right, so we have 1,000 milligrams. Going to grams. Now, this might actually help you if we do it this way, because to go from milligrams to grams, right, we're going to go this way on the scale. Okay. The next one, we're going 500 milligrams. Also going to grams. So again, we're going to go this way on the scale. The next one is 1 milligram. And for this one, we're going to micrograms. So we're going to go down this the other way down the scale. Okay, to the right. And the last one is 110 pounds. Oh, I skipped 1, 2 kilograms. Okay, we missed the 5 liters, 2 milliliters, and that one's going to be to the right. Okay, we'll come back and do that one. Okay, so for the 1,000 milligrams to the grams, we already said we're going to the left. Okay, so we're going to divide by 1,000. We'll move the decimal. So 1,000 divided by 1,000 equals 1 gram. Or if we move the decimal 3 places to the right, the decimal's here. Okay. I'm sorry, to the left. Okay, 1, 2, 3. That would also give us 1 gram. Okay. All right, milligrams to grams, same thing. We have 500 divided by 1,000. Okay, or you can take the 500. Decimal points here. Okay, you're gonna move to the left, 1, 2, 3. And that's gonna make it 0.5 grams, which is what you should have got if you took 500 and divided it by 1,000. Okay, the next one is 1 milligram to 1 microgram. We're going to the right, so we're going to multiply 1 times 1,000 equals 1,000 micrograms. Okay, or you can take this one, which is really 1.0. Okay, and you're going to move that decimal 1, 2, 3. So then you can add 3 zeros, 1, 2, 3. And that gave us 1,000. Okay, the next one was the 5 liters to the milliliters. Again, you're going to the right, so we have 5 times 1,000 equals 5,000. Or 5.1, 2, 3, 1, 2, 3, 5,000 ml. Okay, and the last one, 110 pounds equals kilograms. So we had 110. We're dividing it, right? Kilograms, pounds to kilograms, we divide by 2.2. Equals 50 kilograms, I'm sorry, 50 kg. Okay. Okay, so we got 1 gram, 0.5 grams, 1,000 micrograms, 5,000 liters, or 50 kilograms. All right, so now I'm just going to give you guys a few minutes to convert the top ones. And then we'll talk about the bottom ones, which you should remember. I showed you those on the conversion chart. So do the top ones first. I'll give you a few minutes. Okay, let's go to the whiteboard and see how you did. So we have 140 milligrams. We were going 2 grams, so you should know you're going left. So you should have divided by 1,000. Or you could have moved that decimal, right? 1, 2, 3. Okay. And that should have gave you 0.14, 0.14 grams. Okay. The next one was 2.4 grams to milligrams. So we're going this way, right? So we're multiplying times 1,000. Or you could have moved that decimal. 1, 2, 3. All right, so that would have gave you, should give you 2,400 milligrams. The next one was 187 pounds. And we're converting to kilograms. So we're going to divide by 2.2. Should give you 85. kilograms. Okay, the next one we had was 1.5 grams. Two milligrams. So that would have been times, right? 1,000. Move that decimal, 1, 2, 3. Okay. And that should give you 1,500 milligrams. Okay, and then we have 1 teaspoon. Okay, so 1 teaspoon equals 5 mLs. 1 ounce equals 30 mLs. One tablespoon equals 15 mLs. And 8 ounces. $2.40, and we just got that by taking 1 ounce, which is 30 mLs, times 8, and that gave us 240 mLs. Okay. There you go. Everything's worked out there on the problem for you. All right, so some basic rounding rules, okay? Don't round numbers until the end of the problem unless you're converting weight, then follow the instruction on the question. A lot of times they'll have you round the weight to the nearest tenth and then finish the problem. So read what the author is asking you to do, or what your instructor is asking you to do. So with the decimals, we don't have trailing zeros, and there should be no naked zeros. So I wrote you some example. On the top is the no trailing zeros. So if it's 4, we write it as 4. If it's 4.1, then we would write it as 4.1, but we don't write 4.0. Also, if it's a decimal, okay, we start it with the 0, 0.12, no naked decimals, and that's to prevent errors, okay? Then when you round to the nearest tenth, and we talked about this already, so if the number in the nearest 10th place, which is where that 0.6 is, this is the 10th place, okay? The 0.5 is the 10th place, all right? Up here, the 1.54, that 4 is in the 100th place, and that determines how we're going to round the 10th. Okay, same thing, 1.57, the 7 is in the 100th place, so that's going to help us determine how we're going to round that 5. All right, so if the number, the last number in the 100th place is greater than 5, then in the 10th place, that number is going to go up. So as you see in the example, it went from 1.57 to 1.6. And if that digit in the 100th place is less than 5, then we round it down. So instead of it being 1.6, it would be 1.5, okay? Then rounding numbers unless otherwise instructed, okay? So if it's greater than 1, we round it to the nearest tenth. In other words, 1.234 would be rounded to 1.2, the nearest tenth. If the answer was less than 1, then we would round it to the nearest hundredth, okay? So if our answer is greater than 1, all right, that means it's going to have a whole number before the decimal. As you notice, when it's less than 1, we have a 0 in front of the decimal. That means that number is less than 1, okay? So generally with these, we round to the nearest 100th, and with the ones on top, we would now round to the nearest tenth. For IV calculations, okay, drops per minute has to be rounded to the whole number. mLs per hour has to be rounded to the tenth unless your instructor says otherwise. Sometimes on mLs per hour, they will tell you to round it to the nearest whole number. Capsules and tabulets must be rounded to the nearest whole number. Okay, but sometimes the way test questions are written, you just have to really read what's the question asking me, all right? Tablets, unless otherwise indicated, then you'll assume that they're scored and you round them to the nearest half tablet. All right, let's convert the following. All right, 575 mLs to teaspoons. 90 inches to centimeters. 400 micrograms to milligrams. 5.5 liters to milliliters. 5 tablespoons to milliliters. 360 centimeters. 2 inches. So going back to our whiteboard, let's do the conversions here. Okay, so the first one is asking us to take 575 mLs and take it 2 teaspoons. So for this one, we know that there's 5 mLs per teaspoon. Okay, we have 575. We can just divide that by 5. And that will tell us how many teaspoons. And I got 115. Always do your math twice just to make sure you got the right answer. And then the next one is 90 inches. Equal how many centimeters. So a little trick I use is I know that women, they like their weight in kilograms because even though kilograms is equivalent to pounds, when we look at it in kilograms, it looks smaller. So that's how I remember that when I'm going from pounds to kilograms, I have to divide because women like their weight in kilograms. Now I do the same thing here. Okay, men like their feet measured in centimeters because centimeters is going to be longer than inches. So when we're going from inches to centimeters, we have to multiply. Okay, so we're going to take 90 times 2.54 because that's what our centimeter is equal to. Every inch is equal to 2.54 centimeters. And I got 228.6 centimeters. Okay, the next one we're doing is micrograms. To milligrams, and remember, milligrams is to the left of the micrograms, so we have to divide by 1,000. Or we have to move that decimal. 1, 2, 3. So we should have 0.4 milligrams. And I'm just going to do the math real quick. That's my way of double checking. So I like to always double check my work. Sometimes you can put your math into the calculator wrong, or you just don't look at the problem right and you write something down different than what it should be. So even when I made my PowerPoints, I had to go back and look because I had a couple of typos on them. So, all right, so 400 divided by 1,000, and I got 0.4 milligrams. Okay, the next one we're going to do is 5.5 liters to milliliters. And again, liters to milliliters, we're going to the right. So we're going to multiply by 1,000. Remove the decimal. 1, 2, 3. Okay, so we're going to add 2 zeros. So it should be 5,500. But we'll do the math just to be sure. So 5.5 times 1,000. And I got 5,500. Okay, the next one is 5 tablespoons. Equal how many mLs? Okay, so for this one, you have to know how much each tablespoon is worth. And we know that each tablespoon is 15 mLs. And we have 5. So you should have got 75 mLs. And the very last one is 360 centimeters. Two inches. And again, centimeters is bigger than inches. This is how my guy likes to measure his feet. He's going to be sad because now he has to what? Divide, right? So it's 360 divided by 2.54. And I got 141.7 if I net rounded to the nearest tenth. Now let's go look at our answers and see how we did. Okay, so for the first one, you got 115 teaspoons. Oh, we missed one. For the second one, we got to 28.6 mLs. For the third one, we got 0.4 milligrams. For the fifth one, we got 5,500 mLs. For the third one, we got 75 mLs. Then we got 141.73, but we rounded it to 141.7. And then we didn't do the last one, but it's there. We had 122 kilograms. So you should have multiplied that, right? Times 2.2, because you're going from kilograms to pounds, you're going to multiply. And that would have gave you 268.4 pounds. Next, we're going to talk about intake and output. And intake includes any fluids that are taken in or administered to the client. It can be through various routes like a mouth, a tube, IV. It can include anything that's liquid at room temperature like IV fluids, tube feeds, foods that are liquid, beverages, juice, coffee, soft drinks, milk, tea, etc. Remember, we talked about ice that melts to half its volume. So for 8 ounces of ice chips, you would record 4 ounces. Pudding or items similar to it. So pudding used to be considered liquid at room temperature, but now some say it's a semi-liquid and it shouldn't be calculated. Other sources say to include it. With that being said, ask your professor what they want you to do. For this review, we will include pudding or products similar to it, or we may include it, okay? And if we do, count it as a liquid. Test questions may give you the amount in ounces, but intake and output is recorded in mLs. So to convert ounces to mLs, you simply multiply the amount of mLs or the amount of ounces, I'm sorry, by 30. Okay, so if you have 67 ounces, you would multiply that times 30, and that would give you the total amount of mLs. Output is any fluid that leaves the body, and it can leave through different routes as well. Mostly what's included is urine output, emesis, liquid stool, ostomy, or diarrhea. Wound that drain through a drain tube or chest tube, any suctioning. And then also you do have to consider other output like sweat. It's called insensible losses. Okay. These, you can't measure them, but if a person has a fever and they're sweating or they're putting out extra fluids, then you do have to consider that because they can become dehydrated easily, especially if the intake and output don't match, which we'll talk a little bit about on the next slide. All right, so when intake is less than output, or the output is more than what we're taking in, then we have to worry about dehydration. And this can happen also in combination with that insensible fluid loss. So remember, insensible fluid loss comes in a way of things like sweat, respirations, that kind of thing, stuff we can't measure. The patient is losing too much fluids compared to what they are taking in. If the intake is more than the output, or if the output is less than the intake, then you have to think about fluid overload. The person is probably retaining some sort of fluid. So example, if we take in 4,250 mLs, but we only put out 1,200, then we have to think about fluid volume overload, and we should start assessing the patient for it. All right, so we're going to calculate the patient's intake during an 8-hour shift. Okay, so here is your intake. The patient had 2 pieces of toast with 12 ounces of orange juice, 2 cups of coffee, 24 ounces of ice chips, an IV infusion of Zosyn, 50 mLs, a house salad, 12 ounces of soda, 1 12-ounce popsicle, 6 teaspoons of penicillin. I'm sorry, tablespoons. And then we're going to calculate their output. So they had 500 mLs of urine, 100 mLs of emesis, the wound vac, which was 200, the urine output of 250, and the JP drain of 400. So in this first part, 0800, the only thing we have to calculate was the orange juice. So we have 12 ounces. Again, you take the total number of ounces and you multiply that times 30, because there's 30 mLs in each ounce, and that gave us 360 mLs. The toast is solid, so we don't measure that. The next thing we had was 2 cups of coffee. Okay, a cup is equal to 8 ounces. So we had 8 times 30, that gave us 240 mLs, and we have 2 of those. So we took that times 2, that gave us a total of 480 mLs. Next, we have 24 ounces of ice. Remember, ice is equal to half its volume. So we took 24 and we divided it by 2, or we could have just said 24, half of that is 12, okay? And then we took the 12 times 30, and that gave us 360 mLs. We had 50 mLs of IV Zosyn. We had the house salad and the 16 ounces of soda. So here we're only going to count the soda. So we had 16 ounces, and there's 30 in each ounce, 30 mLs in each ounce. So we took 16 times 30. That gave us 480. And then we had 6 tablespoons of penicillin. There's 15 mLs in each tablespoon. So we took 6 times 15, and that gave us 90 for a total of 1,820 mLs when we added all this together. Now to calculate the output for this patient, okay, we had 500 mLs of urine, 100 mLs of emesis, 200 mLs from the wound vac, 250 mLs from urine, and 400 mLs from the JP drain. So we had a total output of 1450. So we took in 1820 and we put out 1450. So here, are we at risk for dehydration or fluid volume overload? Okay, if you said fluid volume overload, you'd be correct because we actually took in more than what we put out. So those numbers should be fairly equal. Whatever we take in should be somewhat equal to what we put out or vice versa. All right, let's look at the next question. So we have a client on I&Os, okay? And you're going to be calculating his 8-hour shift. If you look at the answer at the bottom, always look at what the question is asking you, and that's at the bottom, okay? So this is calculating our patient's 8-hour I&O for the 0700 to 1500 shift. So we have an 8-hour shift here, and we're going to calculate the I&Os, okay? So we have to calculate anything he took in between 0700 and 1500. Okay, so at 0700, he had 75 mLs infusing. Okay, and so since we're going to look through the statement, I don't see anything that says that the IV stopped. So that IV started at 0700, so that went times 8 hours. Okay. For breakfast, the patient took a 3-ounce cup of coffee. So we have 3 ounces of coffee. He had a 8-ounce cup of milk. So we have 8 ounces of milk and 120 mLs of juice. Then at lunch, he had 4 ounces of ice and 2 tablespoons of penicillin. Now that's our input, okay? Now for the output, the patient had 450 mLs of emesis and 750 mLs of urine. Now we're going to go to our whiteboard. Oh, I didn't know that was that easy. Okay, there you go. Learned something new today. Okay, so we have 75 mLs of the IV. And that times 8. We have 3 ounces of coffee. I'm just going to abbreviate this. Okay, so this is equal to 75 times 8. Let's just do the math there real quick. So that was 600 mLs. Okay, then we have 3 ounces of coffee. So we have 3 times 30, remember, because each ounce is worth 30 mLs. So that should give us 90, but we're going to do it on the calculator just to make sure. Okay, and then we have 8 ounces of milk. So we have 8 times 30. And that gives us 240. And we have 120 mLs. That's already in what we needed. That's orange juice. Okay, so we're going to leave that as is and just add it over here. Then we have 4 ounces of ice. We'll take half of that, which will give us 2 ounces times 30. And that'll give us 60. And then last but not least, we have our 2 tablespoons of penicillin. So 2. And that was 15 times. I'm sorry. Let's write it right so you don't get confused. We had 2 tablespoons, okay? They're worth 15 mLs each. So that gives us 30. Okay, so we're going to add all this together. So I have 600 plus 90 plus 240 plus 120 plus 60 plus 30. And I get 1140. And that's my total intake. Now for output, we only have 450. Plus, that's our emesis, plus our 750 of urine. $1,200. Okay, so difference of 60, not bad, but we still don't want any difference at once. We want it to be as close as we can. Okay, so intake, we should have gotten 1140 and output 1200. And again, I have it all out there for you, so you can see the calculations in case you missed something. All right, so now we're going to do some have over need. Okay, so let's start with the first one. So what you really want to look at is what is the question asking you? Okay, so the question's asking how many tablets will the nurse administer for one dose? All right, so the doc ordered 20 milligrams. That's going to go on top. Physician's order goes on top. Okay, the pharmacy sent 10 milligram tablets. So you have 10 milligrams for each tablet. How many tablets will the nurse administer for one dose? So you have ordered 20 milligrams, and on hand, that's your supply, you have 10 milligrams. Okay. So doctor's order is 20 milligrams. You have 10 milligrams. And it's per one tablet. Okay, so you can really cross out the zeros here, and then it just becomes 2 divided by 1, which should equal 2, right? If that's too confusing for you, you can still do the 20 divided by 10, and you're still going to get 2. And so you're going to get 2 tabs. Okay, next question is patient received 2.5 tablets of ampicillin. Each tablet contains 100 milligrams of ampicillin. Calculate the amount of ampicillin the patient received in milligrams. So for this one, it wants to know how many milligrams the patient received, okay? So first you have to figure out how much each tablet or capsule was worth. And we know that each one was worth 100 milligrams because it gave us that information. Okay, and then how many capsules or tablets did the patient get? They got 2.5. Okay, so now you just have to do the math. 100 times 2.5, and you should have gotten 250 milligrams. Okay, so the first one was 2 tabs. And again, I have everything worked out here for you. Okay. Second one was 250 milligrams. Okay, for physician ordered folic acid 0.8 milligrams by mouth daily. Pharmacy sent to the unit 0.4 milligrams. How many tablets will the nurse administer for each dose? So the doctor's order is 0.8 milligrams. And what we have our supply on hand is 0.4 milligrams. And it wants to know how many tablets. Okay, so our order is 0.8. and we have 0.4. And you're just going to do the math. And that should have gave you 2 tabs. Okay, on this one, the physician ordered digoxin 0.5 milligrams IV now. And the pharmacy sent digoxin 0.5 milligrams per ml to the unit. Wants to know how many mLs of digoxin did the patient receive. So again, you need 2 things here, okay? You need the order, which is digoxin 0.25 milligrams, okay? And your supply on hand, which is 0.5 milligrams per ml. And wants to know how many mLs did we get? Okay, so order is 0.25. And we have 0.5. Our strength on the bottom is equivalent to the strength on the top, and it's per 1 ml. Okay, this crosses out. Then we have 0.25 times 0.5. I'm sorry, divided by 0.5. And that should have gave you 0.5. Okay, so we have 0.5 times 1 ml. And that gives us 0.5 mLs. And that's what we're going to get. Okay, so your doctor's order, 0.25 milligrams divided by what you have on hand, 0.5 milligrams. The milligrams cross each other out. You do the math, you get 0.5, and then you multiply that times 1 ml, and that gives you 0.5 mLs. Okay, so we had 2 tablets and 0.5 mLs. Okay, and again, the math is worked out there for you. So you can see it. Okay, a little bit of conversion here now. The medication ordered is for Xanax, 6,000 micrograms, and the pharmacy delivered Xanax 2 milligram tablets. How many tablets would you administer to the patient? So what we have ordered, or the physician's order, is 6,000 micrograms. And our supply on hand is 2 milligrams per tablet. They want to know how many tablets we'll give. So our order goes on the top, 6,000 micrograms. And what we have on hand is 2 milligrams per 1 tablet. Okay, now students always say, which one do I have to convert, Miss Sue? So real life, you would have to convert the physician's order because you can't convert what you have on hand. If you have milligrams on hand, you can't make it into a microgram tablet, okay? But for this math, it doesn't really matter because the answer should come out the same no matter which one you convert. Okay, so for this one, I'm actually going to convert the micrograms to make this a smaller number to make it easier to work with because I know if I'm going from micrograms to milligrams, okay, I'm going to the left. So I'm going to either divide by 1,000, okay, or I'm going to move that decimal, right, to the left. 1, 2, 3. Now, technically, that should make this 6 milligrams. Okay. Let's just do the math. So we have 6,000 divided by 1,000. I got 6. Okay, and 6 divided by 2 equals 3. So now I have 3 times 1 equals 3 tabs. Okay. So let's write that down. 3 tabs for the first one. A patient is to receive 1.5 grams of a medication and the pharmacy sends a bottle labeled 500 milligrams per tablet. How many tabs will you give? So 1.5 grams, okay, is your order. Your supply on hand is 500 milligrams per 1 tablet. Okay, so 1.5 grams. 500 milligrams. This is our order. This is what we have on hand. Okay, so we have to make the top equal to the bottom. This is grams, this is milligrams. So let's convert this to grams, to milligrams. So we know we're going to go this way on the scale, right? So we're going to multiply. Remove the decimal. 1, 2, 3. All right. So that should give you 1,500 milligrams. Okay, and then again, you can cross out the 2 zeros, cross out the milligrams. Now you have 15 divided by 5. And that is 3 tabs. Okay, so I have the conversions and everything all broken down here for you. And I have it both ways where you can do the multiplication or you can move the decimal, just for those of you who prefer one way over the other. Okay, your patient complains of chest pain. He used to receive nitro 600 micrograms sublingually, and you have nitro 0.3 milligram tablets. How many tablets will the nurse administer? All right. So again, you have an order for 600 micrograms. Your supply on hand is 0.3 milligrams. So here's your order. Okay, so we can either move this and make this micrograms, but we're going to do this one instead. So for this to go to milligrams, we have to do what? Go to the left, which means we have to divide by 1,000. Remove our decimal, 1, 2, 3. So it should give us 0.6 milligrams. Okay, so we got 0.6 divided by 0.3. And you should get 2 tabs. Okay, let's look at the next one. Patient complains of chest pain. He should receive 1.5 inches of nitro paste topically. The ruler is in centimeters. How many centimeters will the nurse administer? Now remember my little tip, okay? Men like their feet measured in centimeters because centimeters is what? Okay, now how are you going to get from inches to centimeters? So we have 1.5 inches and we need to convert. So we're going to multiply it times 2.54 because the centimeters is going to be bigger, right? You should have gotten 3.81. Okay, and I did the math here on the screen for you. Let me just make sure this is still sharing. did something funky on me. Okay. All right, so I'm gonna leave that up just for a couple of seconds, make sure everybody saw it. Okay, so next question is 51 milligrams is ordered for the client and the medication is available at 125 milligrams per 2 ml. How many mLs will you administer? So I just showed you this laid out so you can get an idea, and then we're going to do some of these measuring in liquids. So it's really the same calculation, okay? What you have ordered over what you have on hand or your supply on hand. So if you're looking at the next question, the physician orders gentamicin 50 milligrams IM every 8 hours. The pharmacy sent a vial marked 80 milligrams per 2 ml. How many mLs should the nurse give for one dose? And it says round to the nearest tenth. Okay. So it's asking you how many mLs you're going to give for one dose. So you need your order, which is your 50 milligrams. You need your supply available, which is 80 milligrams for every 2 mLs. So that means for every 2 mLs you give, there's going to be 80 milligrams of this medication in it. The doctor wants us to give 50 milligrams. You have 80 on hand. Per 2 ml. So you know with this, you're not going to give a full 2 ml, right? Because a full 2 ml would be 80 milligrams. And your order is for 20 milligrams. So whatever your answer is here, it has to be less than 2 mLs. Just so that you can think a little bit about what the question's asking you, okay? So really here, we can get rid of these zeros. They can cancel themselves out. Milligrams cancels out. So now we have 5 divided by 8 times 2. Okay, so you can do your 5 divided by 8 first. And that gives you 0.625 milligrams. And then that's going to be times 2, okay? Because that's going to give you how much is in. So we're going to take that times 2. And that gives us 1.25 mLs. So see, we're giving less than 2. We're giving 1.25 mLs. Okay. And then we rounded it to the nearest tenth. So in order to round it to the nearest tenth, you use that 5, and that would take it up to 1.3 mLs. Okay, on our next one, when prepared as directed, the 125 milligram solu-medrol vial provides 125 milligrams per ml. If the patient is to receive 100 milligrams of the medication IM as a single dose, the nurse should draw up how many mLs. So the question is asking how many mLs will you draw up? Okay, so the order is 100 milligrams, okay, because that's what the patient is supposed to receive. Your supply on hand is 125 milligrams per 1 ml. So again, if your patient's to receive 100 milligrams and you have 125 milligrams in 1 ml, that means your patient should receive less than 1 ml. Okay, let's do the math. So our order is 100 milligrams. We have 125 per ml. So now here, you can't cross out the zeros because there's not an even number of zeros. So you can just cross out the milligrams. Then we have 100 divided by 125. And you should have gotten 0.8 mLs. So we have 1 ml there, okay? Because each 125 milligrams is equal to 1 ml. So that's why this is 0.8 times 1 ml. All right, let's look at the next one. The next one says we have a patient's order for heparin 7,500 units, stat, and what we have available is 10 units per ml, and it wants to know how many mLs will we give. So 7,500 units is our order. We have 10,000 units on hand per ml. Okay, so we have 7,500 units ordered. $10,000 is what we have on hand. Again, the units is going to cross itself out, okay? Now we have per 1 ml. So it's now, we can cross out the zeros that are equal. So we have 2 here and 2 here, so we can cross those out. Now we have 75 divided by 100. And that's just to make the math easier. So it should have gave you 0.75 mLs. If you take 7,500 and divide it by 10,000, you should get the same answer. Okay, 0.75 mLs. Okay, so for the top, you had 0.8, and for the bottom, you had 0.75 mLs. Okay, the next one is Keflex. It comes in a concentration of 250 milligrams per teaspoon. The order reads give 750 milligrams, and it's asking you how many mLs will you give. Okay, so first, what we have on hand is 250 milligrams per teaspoon. And our order is 750 milligrams. Okay. So again, your order goes on top, 750 milligrams. We have 250 milligram per 1 teaspoon. Now we're going to convert this to 5 mLs because we know that's what a teaspoon is worth. Okay, cross this out. Cross this out. Now we have 75 divided by 25. Should equal 3, okay, times your 5. Equals a total of 15 mLs or 3 teaspoons. Let's look at the other problem there. Okay, this is asking us about Tylenol. We're going to give 180 milligrams every 4 hours for a temperature above 101. It comes in 100 milligrams for 5 mLs. How many mLs we give in each dose? Okay, so the order is 180 milligrams. We have 100 milligrams per 5 mLs. How much are we given for each dose? So we just have to calculate one dose here. Okay, so we have 180 milligrams ordered. On hand, we have 100 per 5 ml. Again, you could cross this out. 0 in the milligrams. You can only do 1 0, remember, because there's only 1 0 on the top. That should give you 1.8 times 5. For a total of 9 mLs. All right, that took me a second, but hopefully we're on the right screen now. Okay, so this was for the Caflex and the Tylenol we just did. Okay, next, we're going to be calculating the flow rate in mLs per hour. Okay, so if you were infusing 250 mLs over the next 120 minutes, what would be the flow rate in hours? Okay, so your time has to be in hours, and then you need your total volume. Those are the two things that you're going to need to calculate ml per hour. So the first thing you have to do is convert that 120 minutes to hours, and you take the minutes, the total number of minutes, and you divide it by 60 because there's 60 minutes in an hour. So if you took 120, divided it by 60, that would give you 2 hours. You have 250 mLs total, and you're dividing that by the 2 hours, and that gives you 125 mLs per hour. Same thing here. The difference is you don't have to convert because your time is already in hours. So remember, look at what the problem's asking you. This is asking you for mLs per hour. Okay. So if you're doing mLs per hour, you need your total volume and your time in hours. Total volume was 1,000. Time in hours was 10. So that gave us a rate of 100 mLs per hour to set the pump at. Here we go. We have a liter of D5 and normal saline with 20 MEQs of potassium chloride to infuse over 24 hours. How many mLs per hour will the nurse set on the IV pump? Round to the nearest whole number. Remember to check what is the question asking you. So this is asking for mLs per hour. For mLs per hour, you need your total volume, and that's usually in mLs, but in this case, we have a liter. So we have 1 liter, that's our total volume. Okay, and it's going over 24 hours. So we have our total volume, which is 1 liter. We want that to be in mLs. So we know that 1 liter is equal to, we're going to multiply it by 1,000, right? Because we're going from liter to milliliter. So we're going to the right. Okay, so we have 1,000 mLs. And it's going to be divided over 24 hours since our time is already in hours. Okay, that's going to give us an answer that is equivalent to mLs per hour. So we take 1,000 and we divide it by 24. And you should have gotten 41.6. They want us to round it to the nearest whole number. We're going to use the 10th place to do that. Since this is 5 or greater, this would be 42. Okay, let's look at the next one. The next one is 1,200 mLs of lactated ringers is prescribed to run over 30 minutes. How many mLs will the nurse set the pump for? Okay, so let's go to our drawing board. Remember, it's asking us for mLs per hour, okay? So we have a total of 1,200 mLs because that's what we need is our total volume in mLs, right? And then we need our time in hours, but our time was 30 minutes. So now we have to convert our time into minutes, and we already said in order to do that, right, we're going to take the number of minutes, which is 30, and divide it by the total number of minutes in an hour, which is 60, okay? And when you do that, you should get 0.5. So now we can convert this to 0.5 hours. We can take our 1200 and divide it by 0.5. And that should give you a total of 2,400 mLs per hour. And here's your math worked out for you. Okay, again, remember to look at what your question is asking you. Okay, so the patient is to receive 1250 mLs of sodium chloride over 10 hours. What rate would the nurse set the IV pump to? And it's asking us mLs per hour. So again, our total volume is in mLs, and we see that our total volume here is 1250, and our time we want in hours. Our time is already in hours, so that's a good thing. So now we can just go to the whiteboard. Okay, we know that we have a total volume of 1250. Our time is already in hours. So we're just going to divide that by 10. And it will automatically, this is hours. So you see it's going to give us mLs per hour. So 1250 divided by 10. And you should have gotten 125. 125 mLs per hour. Let's look at the next one. Physician orders a patient 450 mLs of dextrose, 0.5% in normal saline to be administered in 90 minutes. What rate would the IV pump be set to? So this should be mLs per hour also. All right, so we're calculating mLs per hour. So let's go to the whiteboard. We know that our total volume is 450 mLs. And our time is 90 minutes. So what do we have to do here? All right, so if you said convert our minutes to hours, you're correct. And we do that by taking our 90, dividing it by 60. And that should have gave us 1.5 hours. Just going to do the math on my calculator to make sure. Okay, I got 1.5. So now we have 450 divided by 1.5. And we should have gotten 300 mLs per hour. Now, if we go to our next page, our answers should be there. Okay. For the first one, we got 125 an hour, and the second one, we got 300 mLs per hour. And again, it's all written out for you. Okay, medication is set at a rate of 70 mLs per hour at 9:05 with a volume of 200 mLs. Calculate the infusion time and the completion time and round it to the nearest tenth. Okay, so the first thing we're going to need here is to calculate our infusion time. So in order to do that, remember we need our total volume, which is 200, and our rate, which is running at 70 mLs per hour. Okay, so that's going to give us, those two things will give us the amount of time that it's going to run. Then it's asking us what time it will complete. Okay, we started at 9:05 p.m. Okay, and it wants us to round to the nearest tenth. All right, so now let's go to the whiteboard. All right, and the first thing we're going to do is we're going to take our total volume of 200 and we'll divide that by 70. And that's going to tell us how long that the pump is going to run for, how many hours. Okay. So 200 divided by 70 is 2.85 hours. Okay. So we're going to take that 2.85 and we're going to use this 5 and we're going to round it up, okay, to the nearest tenth. So this would be 2.9 hours. Okay, now the next thing it asked us to do was to calculate the infusion time. Okay, it started at 9:05. p.m. Okay, so the 2 hours is easy. We can just take the 2 hours and add it here. Okay, and that brings us to 11:05 p.m. All right, but we still have 0.9 hours. So how do we calculate that into minutes? Okay, so we're going to take the 0.9. And we're going to multiply that times 60. Okay, and that will tell us, because 0.9 is a fraction of that 60 minutes. So that will tell us how many minutes that 0.9 hours is equal to in minutes. Okay, so 0.9 times 60 gives us 54 minutes. We're going to add that here. And that gives us a final infusion time of 11:59 PM. Okay. And that'll be all out on the board for you on the next slide. Okay, medication rate of 70 with a volume of 200. Your total volume is 200 divided by the 70. That gave us 2.85 hours. We rounded it up to 2.9 hours, and that's our infusion time. Okay, so we took the okay, so our infusion time was 2.9 hours. We started at 9:05. If you add 2 hours to 9:05, that brought us to 11:05 p.m. Then we took the 0.9 hours that were left over. Okay, we multiplied that times 60 minutes. That gave us a total of 54 minutes. We added that to the 11:05 p.m. and that gave us a completion time of 11:54 p.m. Okay, next we're going to go over drop factors. All right, so for drop factors, your formula is going to be your total volume in mLs, your total time in minutes times your drop factor, and that's going to equal your flow rate in drops per minute, and it's going to be a whole number. Okay, so look at the first one, calculate the IV rate for 1200 mLs of normal saline to be infused in 6 hours. The infusion set is calibrated for a drop factor of 15 drops per minute. So here, your total volume is 1200, okay? And that goes on the top. And then you're going to convert your 6 hours to minutes, okay? So 6 hours times 60 minutes in an hour equals 360. So now our hours is converted into minutes. Okay, so we have 1200 mLs divided by 360 minutes by 15 drops per minute. And that gave a total of 50 drops per minute. Don't worry, we're going to do a couple of these on the whiteboard and hopefully you'll get it. Okay, so next one is we're going to calculate the IV flow rate for 200 mLs of normal saline over 120 minutes with a drop factor of 20 drops per ml. So again, you need your total time volume in mLs, your total time in minutes, and your drop factor. And here you have your total volume in mLs, so that's 200. Your time is already in minutes, so no conversion there. All right, so it's 200 divided by 120, and then you're going to multiply that times the amount of the drop factor. And in this case, it's 20. And that gave you a total of 33 drops per minute. All right, let's try some. All right, so the order is to infuse D5, 1000 mLs over 3 hours using the IV set that delivers 10 drops per ml. What would the infusion rate be to the nearest whole number? So again, you need your total volume in mLs. So that is 1000 mLs. You need your total time in minutes. For now, we're just going to take our total time, which is 3 hours. Okay. And you need your drop factor, which is 10. We're going to go to the whiteboard. Okay, we have our total volume, which is 1000 mLs. We're doing drop factor here. We have our total time, which is 3 hours. Remember, that has to be converted to minutes, because your time has to be in minutes. So we're going to take this times 60. And that's going to give us 180 in minutes. And then our drop factor is 10. Okay, so let's do the math. 1000 divided by 180. And then you're going to multiply that times 10. And you should have got 55.5. And then because it has to be a whole number, this number decides. So it's going to be 56 GTT per minute. Okay, the second order is the physician orders red packed blood cells to infuse at 50 minutes. The unit contains 400 mLs and the tubing administration set has a drop factor of 10. The flow rate for the infusion of red packed blood cells is how many drops per minute. So again, drops per minute, you need the total volume in mLs. And in this case, we have 400 mLs. We need the total time in minutes. And in this case, it is in minutes and it's 50 minutes. And then we need the drop factor, which is 10. All right, here we go. So our total volume is 400. We're going over 50 minutes. We have our time in minutes. And times our drop factor of 10. So now you can just really do the math. It's 40 divided by 5, which should give you 8. And then you're multiplying that times your 10. Okay, which should give you 80 drops per minute. Okay, so we got 56 for the first one, and we got 80 for the second one. And everything's all written out for you. Okay, let's look at the next one. Administer 250 mLs in 80 minutes using a micro drip set. Calculate the drops per minute to the nearest whole number. So again, you need total volume, which here is 250 mLs. Your total time in minutes, which is 80 minutes already broken down for you, times your drop factor, and that says micro drip. So who remembers what that is? Okay, let's go to the whiteboard. Okay, so we have our total volume, which was 250. Our time was 80 minutes. And then we had a micro drip, okay? And for those of you that remembered, great. For those of you that didn't, it was 60. Okay, remember PD drips, micro drips are 60 drops per minute. So now we have 250 divided by 80 times 60. And let me just do my math again. Okay, so 250 divided by 80 times 60. So you should have got 3.125 times 60. Should have give you 187.5, and then they wanted us to round it up, so that would have made for 188 drops. Okay. Now, if we look at our second problem, okay, we have an IV of 1500 mLs. It's supposed to infuse over 6 hours. After 1 hour, 400 mLs has infused. Recalculate the drops per minute rate to complete on time to the nearest whole number of 15 drop set is being used. So for this one, first you have to calculate how much went out of the IV, okay? So we have 1500 mLs infusing over 6 hours, and after 1 hour, 400 has infused. So 1500 minus 400 gives us 1100 mLs now that we have. Okay, and then we have to recalculate the drop rate to complete on time. We started with 6 hours. It's been 1 hour. So that leaves us with 5 hours. And remember, our time will have to be converted to minutes. So let's go to the whiteboard. Okay, so again, we started with 1500 mLs. $400 went out. That left us with 1100 mLs. So that's our total volume because we're calculating the drip rate, remember. So our total volume is 1100 mLs. Our time was 6 hours and 1 hour went past. So now we're at 5 hours. We're going to take that times 60 to get our minutes. So now we have 300 minutes. So we have 1100 mLs over 300 minutes. And our drop factor was 15. So now you have to do the math. 1100 divided by 300. That gave you 3.666 times 15. And that should have gave you 55. So that should have been 55 drops per minute. And again, I wrote it out for you. Okay, your conversions and all. Okay, our next problem is 150 mLs per hour in 120 minutes using a PD drip set. Calculate drops per minute. So you remember what the PD drip is. So we have 150 mLs. That's our total volume. We're giving it over 120 minutes. And our PD drip is what? 60, correct. Let's go to our whiteboard. Okay, we have 150. That's our total volume. Our total minutes is 120. And our drip factor, we said, is 60 because it's a PD drip. So now we just have to do the math. 150 divided by 120 times 60. And that should have gave you a drop factor of 75. Next one is we have 700 mLs. It's going to infuse in 3 hours. After 1 hour, 250 has infused. Recalculate the drip rate to complete on time. So we had 700. 250 went out. That should have left us 450 mLs for a total volume. And it's started to go over 3 hours. 1 hour has passed. So we should have 450 mLs in 2 hours. And we're using a PD drip. I'm sorry, we're using 20 drop factor. So our drop factor is 20. Okay. So here we go. We have 450 mLs that was left. Okay. Because we started with 700 and 250 went out. So that left us with a total volume of 450. Our time was 3 hours. 1 hour went by. That left us with 2 hours. We multiplied that times 60. And that gave us 120 minutes. And our drop factor was 20. So we have 450 divided by 120 times 20, which also should have gave you a drip factor of 75. Okay. And there it is all spelled out for you there. Okay, now we're going to do a little bit of reconstitution. Okay, so this is asking us how many mLs we're going to give. Okay, and so okay, so again, you're going to start with what your doctor ordered because that goes on the top. So our doctor ordered 200 milligrams. It doesn't really matter what it is. Okay, and then it says dose available, reconstitution directions, add 2.3 mLs of sterile water to make kanamycin 1 gram per 3 mLs. How many mLs would you get? So on hand, or our supply that we're going to end up with, it's the 1 gram per 3 mLs. So that's going to be our supply on hand. So let's go to the board. Okay, and we know that we have 200 milligrams ordered. And we have 1 gram for 3 ml. Okay, for this, we're going to go ahead and take this 1 gram. We know that 1 gram is equal to 1,000 milligrams, so we need to convert that. This way we have milligrams on the top and milligrams on the bottom. Now we have 200 divided by 1,000. Times 3. And that should have gave you 0.6 mLs. And that's what we're going to give. Okay, our next one, we have 1,000 milligrams of Ticar. Our reconstitution instructions say add 2 ml to make 1 gram per 1.6 mLs. So that's our supply on hand, 1 gram per 1.6 mLs. So we have 1,000 milligrams. For 1.6 ml for the Tigar. So we have 1 gram per 1.6 ml. Okay, this converts to 1,000. Okay, so we have 1,000 divided by 1,000 equals 1 times 1.6 equals 1 0.6 ml. Okay, so again, we had 200 milligrams ordered on hand. We had 1 gram per 3 ml. We took the 200 milligrams. We would divide it by 1 gram, but you can't. You have to convert it. So we converted that 1 gram to milligrams. All right, so now we have 200 divided by 1,000 times 3, and that gave us 0.6 mLs. On the next one, we had 1,000 milligrams IM every 6 hours. So what we have on hand is 1 gram per 1.6 mLs. We converted the 1,000, the 1 gram to milligrams, okay? So now we have 1,000 divided by 1,000, okay? And that gave us 1 times 1.6, which gave us 0.6 mLs. So we converted the 1 gram to milligrams by taking 1 times 1,000. All right, and that gave us a total dose of 0.6 mLs to administer. I'm sorry. 1.6, that should have been. Okay, so it should have been 1.6 mLs. So we had 1,000 divided by 1,000, which gave us 1, and then we multiplied the 1 times the 1.6, and that gave us 1.6 mLs. Let's look at another one. So for this one, we had Solu-Cortef, 150 milligrams. We had a vial of Solu-Cortef powder, and the directions were add 1 mm of sterile water. And what we were going to end up with is a solution of 250 milligrams per ml. So that's our supply on hand. So we have ordered 150 milligrams. That's our order. What we have on hand is 250 milligrams per ml. So that's our order, 150, and what we have on hand is 250 per ml. So you're just going to do the math here. 150 divided by 250. Times 1, and that should have gave you 0.6 mLs. Okay, let's look at the next one. Next one said we had Pfeifferson 1 million units. Okay. And we reconstituted it by adding 1.6 mLs of sterile water to make a concentration of 5 million units per ml. And we're going to calculate the amount of mLs that we're going to get. Okay, so we're here at the drawing board. We have 1 million units ordered on hand. We have 5 million units per ml. Okay, so again, units would cross themselves out. And so will the zeros as long as you have an equal number. So we have 1 here, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So we can cross all those out, and now it just becomes 1 divided by 5. Now, if you want to do the 1 million divided by the 5 million, go for it. It's a lot of zeros to put in the calculator. So I'm going to do both. 1 divided by 5, and I got 0.2. And I'm taking that times 1, so that should give me 0.2 mLs. And now I'm going to do the same thing. I'm going to take the 1 million, 1, 2, 3, 4, 5, 6, and I'm going to divide it by the 5 million. 1, 2, 3, 4, 5, 6. Okay. And I get 0.2. All right. So just to make your math easier, and it makes it a little easier, especially if you're doing it on something like ExamSoft or in a computer program. Okay, so again, I wrote these out. I even talked to you about counseling out the zeros to help you do the math a little bit easier, okay? All right, physician ordered verapamil hydrochloride, 7.5 milligrams, IV push over 3 minutes. Okay, so what does this mean? We have to give this drug slowly, okay? So what we're going to do is we're going to calculate out how much we have to give every 15 seconds so that we give it correctly over those 3 minutes. So if every 15 seconds we're pushing a little bit, a little bit, a little bit until we get up to 3 minutes, then we know we've given the dose correctly and hopefully it doesn't cause any harm to the patient. Okay, so first thing you have to do is figure out what the doctor ordered. So the doctor ordered 7.5 milligrams, okay, over 3 minutes. And what you have on hand is 2.5 milligrams per ml. And it wants to know how much in 15 seconds, okay, every 15 seconds. All right, so we're going to just go back to our old formula, which is what did the doctor order? Okay, so the doctor ordered 7.5 milligrams. And it's over 3 minutes. Okay, that's our total dose. Okay, what we have on hand is 2.5 milligrams per ml. So what we're going to do is we're going to just move this 3 minutes here to up here. We know that we have this ordered and this on hand per 1 ml. So that's our total dose, okay? So let's first figure out how much we were going to give over the total 3 minutes. All right, so 7.5 divided by 2.5 times 1. And that equals 3 mLs. Okay, so we're going to give 3 mLs over 3 minutes. Now it wants to know how many we're going to give in 30 seconds. I mean, in 15 seconds. Okay. So how much in 15 seconds? Okay. So the first thing to do is let's take the 3 and let's multiply that times 60. Because we know that there's 60 seconds in every minute. Okay. So that gives us a total of 3 mLs over 180 seconds. Now it wants to know how much in 15 seconds. So if we take 180 and divide it by 15, we're going to divide here. Okay. That tells us we're going to give this a total of 12 times in 15 seconds. Okay. So now we can take our 3 and divide it by 12. And that'll tell us how much we're giving each 15-second period. Which should come out to 0.25 mLs. Okay, and I worked this out for you here. All right, so that you can calculate and see how I did the conversions. Okay, let's look at this one. Our physician ordered warfarin, sodium 3 milligrams, IV push over 1 minute. So we have 3 milligrams ordered over 1 minute. Okay. And okay, so the physician ordered warfarin sodium 4 milligrams IV push daily over 2 minutes. Dose available is warfarin sodium 2 milligrams. Calculate how much to give every 15 seconds. So we're going to do the same thing here. We have 4 milligrams ordered to give it over 2 minutes, and we have 2 milligrams per ml. Okay, so we have 4 milligrams over 2 minutes. We have 2 milligrams per ml. Want to know how many to give each 15 seconds. All right, so the first thing we're going to do is the total for the 2 minutes, which is the 4 divided by the 2. So that gives us 2 milligrams times 1, which equals 2 mLs that we're going to give over 2 minutes. All right, and then we're going to take 2 times 60 because we know that there's 60 seconds in a minute. That will give us 120 seconds. We'll divide that by 15. That gives us 8 15-second intervals. We'll take our 2 mLs and divide it by 8. And that gives us 0.25 mLs per 15 seconds. And again, we have that worked out for you on the board so you can see it. Okay. Okay, given the weight of a patient and a dose specified in terms and weight, calculate the necessary dosage. These problems are a type of pediatric dosage or critical care, okay? So we have the weight in kilogram and we're trying to figure out the dosage per kilogram. So the doc orders 200 milligrams of Rocephin to be taken by a 15.4-pound infant every 8 hours. The medication label shows that 75 to 150 milligrams per kilogram per day is the appropriate dosage range. Is this doctor's order within the desired range? Okay, so really all I want you to get out of this is that the 15.4 pounds has to be converted to kilograms. So we're going to convert by dividing by 2.2. Remember, our kilograms should be smaller. So we have 15.4 pounds divided by 2.2, and that gives us 7 kilograms. Okay, and then you're going to take that 7 kilograms. If you were doing a safe calculation, you would multiply it times the lowest possible dose, which is 75 milligrams per kilogram, or the highest possible dose, which is 150 milligrams per kilogram. Okay, so the lowest possible dose for this infant that we would want to give would be 525 milligrams per day. And that would be divided over however many doses. So if it was 6 doses, we would divide that 525 by 6. Okay, if it was 4 doses, we would divide it by 4. And the same thing, the highest possible desired dose we would want to give over a day would be 1,050 milligrams. And then we would take that total dose and divide it over the amount of doses. So the doc could order anywhere between that range and it would be safe for this infant. And that may vary with different kids based on any sort of disease processes that they have, how often they get the infection, how many times they've taken this medication, how they've responded to it. So all those things are going to play a part. All right, so when we do the calculation, we're just going to do the basic dose based on the kilogram, okay? So the order is for ANSEF, 20 milligrams per kilogram a day for a child who weighs 77 pounds. And we want to know how many milligrams should be administered per day. So we have 20 milligrams per kilogram and our child weighs 77 pounds. Okay, so let's go to the whiteboard. All right, we have 20 milligrams per kilogram ordered. Our child weighs 77 pounds. I'm going to divide by 2.2. I think that's going to give us 35 pounds. Okay, it does. That gives us 35 pounds. I mean, kilograms, I'm sorry. And then we're going to multiply that times the 20 milligrams. And that gives us our total amount of kilograms ordered for the day. So 35 times 20. So our doctor ordered 700 milligrams for this patient for the day. Okay. And again, that would be divided up into the number of daily doses that we're going to give. You just have to look at what is the question asking you, because that's going to tell you how to break that down. The next question is, asking us, the doctor orders penicillin, oral suspension, 35 milligrams per kilogram per day in 3 divided doses for a client who weighs 75 pounds. The suspension available is penicillin 100 milligrams per 5 ml. What volume should the nurse administer for each dose? So for this one, you have to first calculate the total daily dose. Okay, so you're going to do that by taking your 35 milligrams and multiplying that times the patient's weight in kilograms, which is 75 pounds. Okay. So we're going to take 75 and divide it by 2.2. And we have, I believe, 35 milligrams per kilogram. And then what we have on board is 100 milligrams per 5 ml. Okay, so 75 divided by 2.2 is going to give us our patient's weight in kilograms. So that should have gave you 34.099 something. And we're going to multiply that times 35. So now you should have 1193.18. Okay. So that's your total dosage for the day. Okay. You're going to divide that by your 100 milligrams. And multiply times 5, and that should have gave you 59.659. And then we divide that by 3. And it should have came out to about 20 mLs. Okay, so this 59.65 is going to round up to 60 mLs per dose according to this. Okay. So here that is marked out for you. Okay, doctor orders 10 micrograms per kilogram per minute of a dopamine infusion. The patient weighs 170 pounds. Dopamine is supplied as 500 milligrams per ml. How many mLs per hour will you administer? Round to the nearest tenth. Okay, and that concludes this session of math. Hope to see you again soon. If you have questions, please reach out.